Hello! As part of our demonstrational series, today I'll be covering indoor through-wall sensing using Ancortech's 580AD SDR-Kit. The 580AD kit is a software-defined radar operating with a center frequency of 5.8 GHz and a maximum bandwidth of 400 MHz. The AD, or Advanced, is our second generation of software-defined radars. Of the changes made, the most important is the addition of a fractional end phase lock loop to help achieve better linearity in frequency modulation applications. This results in better target detection and an improved range resolution. The kit contains everything you need to get up and running, including the processing module, the RF module, a pair of 5.8 GHz patch antennas, and all of the RF, data, and power cables you'll need. You can find more about this device by visiting the link on the upper right-hand portion of the screen. For today's experiments, I'll need a mobile radar platform. I started by working with an acrylic plane affixed to a tripod. This will allow me to easily transport the platform and keep it in a rigid position during collections. Next, I attached the transmit and receive antennas, placing the SDR module in the middle. To control and communicate with the radar, I'm using an embedded Linux module running Ubuntu. I'll be able to govern the operation and parameters of the radar, as well as transmit my collected data back to the laptop over Wi-Fi. Finally, everything is powered using a 10 amp hour 5-volt lithium battery pack, commonly used for recharging a cell phone or tablet device. In these photos, you can see the entire assembly, as well as the embedded Linux module and the battery pack on the rear. As a general illustration for the videos to follow, most of the scenes today will involve observing the motion of a moving object in another room. The 580AD module, centered at 5.8 GHz, works very well for this application. As shown in the cartoon, you can imagine an interesting object stationed in Lab C. The radar will be placed in an adjacent room, Lab A, and will transmit its collections to a PC which can be anywhere a Wi-Fi signal is present between the two devices. In this case, I'm running an access point on the laptop, so as long as the two devices are within 10 to 20 meters of each other, everything should work out just fine. Alright, so this is the Ancortech 580AD. It's centered at 5.8 GHz, it has 400 MHz of bandwidth, and we're going to be running FMCW sweeps using it. Now we're going to be placing this today behind various walls, everything from inside drywall to cinder blocks and concrete, to wood, different things. What we have here is we have two antennas, one transmit and one receive. We have the 580AD module from Ancortech, and then on the back we have an embedded Linux module, and this is all hooked up to a 5-volt battery. The battery supplies power for both the radar and for the embedded Linux module, and there's a Wi-Fi card put into the embedded Linux module so that I can stream data off of the radar and onto MATLAB, which is on the laptop, and we're going to use that for visualization. So first thing up, let's go ahead and put this behind the drywall here. There's a lab just on the other side of this wall, and we're going to walk around the hallway and we're going to observe the motion. So hang tight. Alright, so we have everything set up here now. What's going to happen is the radar is facing outward into the hallway, just on the other side of this wall. This is just regular office drywall. We have SSH'd into the embedded Linux module and started our C++ application. That application is going to go ahead and grab samples off of the radar. It's going to packetize them, and it's going to send them via Wi-Fi over to our laptop. Our laptop's running MATLAB. It's got an open UDP port, and it's going to go ahead and grab those samples and run FMCW imaging on them. We're going to be able to extract Doppler and range and see what's moving inside that hallway, or through the wall. All right, let's go try it out. Alright, so we have placed the radar on the other side of the wall. It's inside the lab now. It's facing us directly, and it's about a foot and a half off of this wall. What I have here is the laptop that it's streaming all of its collected data to, and we can run visualizations, or the FMCW imaging, in real time in MATLAB. There are other ways to do this, but this is the easiest way to get it up and going. So what's going to happen is that as I move back and forth, and I'll put a segment of what you're seeing on the screen in MATLAB, you can go ahead and see the motion, my Doppler going back and forward. on the screen. So I'll set the laptop down here, and we can go ahead and just walk around. Now you're not going to get too much as I cross perpendicular to it, but as I basically move forward and backwards parallel, that's when you'll see the largest Doppler changes. All right, so this is another great example. Right now we have the radar placed up against a cinder block. This is a stairwell fire escape. There's cinder block right here. We have a metal fire door right here. The radar is facing through the wall. And on the other side, I can go ahead and start walking around. I'm going to close this door now. We have a video camera on the other side. We have a laptop over here, wireless and connected so that we can view it. Pretty cool, huh? All right, so this is the other side of the wall. We're actually in the stairwell now, the fire stairwell. You've got the metal fire door right here. On the other side, sitting behind the cinder block, we have the radar. It's pointed into the stairwell. It goes through the cinder block here, and we have our laptop over in the corner. Go ahead and collect all that motion data. So as I continue to walk back and forth, you can still see that motion on there even with the door closed and through the wall. All right, so in this setup, we have the 580 AD. We're sitting outside in a hallway right now, and we're facing inward looking into a large classroom. We've got the embedded Linux module streaming the radar samples over to our laptop, and we're running MATLAB so that we can do real-time FMCW range Doppler imaging. So what's going to happen now is I'm going to walk into the classroom, and I'm going to walk around in circular motions and back and forth towards the radar, and we're going to see the Doppler range changes that we collect. So I brought the laptop into this room, and what's going to happen is I'm going to pan in and out of what the laptop sees and what you'll see with the camera. The radar's been set up just on the other side of this wall. It's out in the hallway, and it's looking inwards towards the wall, or inwards towards the classroom. So I can walk around the classroom here, and you should be able to get some nice responses of a new target. It will go ahead and show my range from the radar itself, and it will show my Doppler velocity as I move backwards and forwards. You can walk right up to the radar on the other side of the wall, and you should get a nice, strong power return. And as I walk farther away, that return is going to get weaker until it drops out. All right. So we've gotten some excellent through-wall sensing results with Ancortex 580 AD device. Again, it's centered at 5.8 gigahertz. It has 400 megahertz of bandwidth. All of that's adjustable. Today we're using FMCW, but you've got a number of other options to choose from. For more information on this device, visit www.ancortech.com.